All right, these are the derivative basics. So they're going to be some basic formulas that we have for most of our derivatives. So instead of sitting there and doing the limit of the difference quotient over and over and over again, you can apply these rules to make it a lot quicker. So some notation. The d dx of y, this means the derivative of y with respect to x, and that's our y prime. And so in order to find our derivative, we're going to put a d dx in front of our x to the n, and it's going to give us n x to the n minus 1. So where did this come from? Well, if you take the limit of the difference quotient on that, then that's where it comes from. And so we're only going to do it once here. You don't have to write this down if you don't want to. We're going to do it once just to show you where it comes from, and then you just apply the formula over and over and over again. It's like we've done before. So if f of x is equal to x to the n, then we're going to find our derivative. This is our f prime of x. And so first we're going to find f of x plus h. So I plug in x plus h to the n, and I use my binomial expansion on it. You can see they all have h's. Remember, they expand. So the second one goes h squared, h cubed, h to the fourth, all the way to h to the n. And so we end up with x to the n. And so now if we subtract it, these first terms cancel. And we end up with this. And then what's going to happen when we apply the h? It will cancel one of the h's. So you should have done this a lot now to where you know what's going to happen because we've done the difference quotient a lot. So now we have n x to the n minus 1, and then the rest of them all have h's. So what happens when you apply that h to the 0? This goes to 0, and all of them go to 0 except for the first term. So that means our f prime of x is equal to n x to the n minus 1. So that's where our formula comes from. We have x to the n, apply the limit of the difference quotient, and you get this formula. So all that means is you're going to, if you notice there's an n here, we're putting it in front, and then we subtract 1. It's very fast. So our derivative here would be you bring down the 3, and then you subtract 1. So y prime equals 3x squared, and that's it. No limit of the difference quotient needed. Just bring it down. So same thing here. Y prime would equal, bring down the 5, subtract 1. You get x to the 4. And you're going to get really, really quick at this. So this would become y prime equals 2x, because you don't have to even subtract the 1. Y prime equals 7x to the 6. And y prime equals 9x to the 8. That's it. So you bring the number down, the exponent, and you subtract 1. Bring the exponent down, subtract 1. All right, and this one is the same idea. You're just thinking there's a 1, but I'd like to have another rule for it. So you would bring down the 1, and it would just become a, because 1 take away 1 is 0. So if you had a to the x to the 1, this would be 1 times a, x to the 1 minus 1, which is a, x to the 0, which is just a. But it's just a lot easier to think of it as a slope. Remember, these are slopes of the tangent. So if you're dealing with just a to the x, the a is the slope. So what's our slope here? 3. What's our slope here? 5. What's the slope here? 6. What's the slope here? Negative 10. So if you have just x, no exponent on it, it's just the coefficient that you're writing each time. And so this next one, if there's no number there, you put a 1. All right, so there's your general power rule. What about constants? Well, constants, we already should know this. If you have a constant, the slope of a constant is 0. There is no change whatsoever. So if you have a constant, it's 0. So y prime here would be 0. Y prime here is 0. Just think about the graph of y equals 6. It's a horizontal line going through the point 6 for y. And so the slope here is 0. So that means your derivative is also 0. So y prime here is 0. Y prime is 0, and so on. So if you have a constant, it's 0. All right, so now let's put all of this together. If there is a coefficient with x to the n, then all you're going to do is multiply that a and n together. So we're going to do this first one slow, and then the rest of them you're going to do quickly. So this would be 4, and then we bring the 3 down. So times 3, x to the 3 minus 1. So our y prime would be 12x squared. So if you notice, all you're doing is multiplying the 4 and 3 together and then subtracting 1. So our y prime here would be 5 times 7 is 35, and then you remove 1. y prime here. So what is 2 times negative 1? Negative 2. And you subtract 1. Y prime here, and make sure you're writing y prime too, because we want to make sure it's the derivative, nothing else. And so 7 times 3 is 21. X to the 6. It's pretty nice, right? No difference quotient here. Y prime equals, and so with fractions, if you're not quite great at them, then you kind of want to write them out. Times 9, x to the 8th. And so that 9 and 18 simplify, giving us 5/2, x to the 8th. You can also just use your calculator. So if you just plug those fractions in to the calculator, you would just go 5 divided by 18 times 9, hit enter, math, fraction, and that decimal's fine as well, 2.5, and then put either one in front. You can even do alpha y, fraction, 5 over 18 times, should get out of that fraction though, times 9, hit enter, and you can see it's 5/2 as well. So there you have it. There's our general power rule. Thank you.